Hey guys, welcome back to Better C Sharp. We're gonna be talking about source generators today. I'm gonna be honest, I've tried to record this like 10 times, and the quickest I've gotten it is like 50 minutes. So this time I'm gonna try and go through it quite quickly. So with all that in mind, what are source generators? They're brand new to .NET and C Sharp specifically. They are a way for us to do metaprogramming in C Sharp. Other programming languages have had metaprogramming facilities. C++ has template metaprogramming. Rust has like procedural macros. So the reason these are important is that it allows us to use code to generate more code, right? So we can basically generate some code at compile time. And so we can inspect the abstract syntax tree and even the semantic model at compile time. So that's pretty awesome. We're going to talk more about that in a minute. It uses the standard Roslyn APIs. This is also very awesome, and we're going to talk about these a little bit as well. It's a good possible replacement for some reflection-based code. So a lot of the things that you can do with reflection, honestly, we've been pretty spoiled with reflection in C Sharp. For a long time, it's let us do many of the metaprogramming things we've wanted to do, but at runtime, right? And that comes with like a performance hit because you have to do that reflection work at runtime. So doing it at compile time is going to be better, obviously, because then we don't have to do it over and over and over, right? We do it once, we do it offline, and it's great. Let's see. We can generate boilerplate code that users of whatever library would have to write. So, like, if there's times where you kind of, as a library writer, you kind of expect the type of code that a user is going to be able to write, but you can't exactly write it for them because you don't know their types and exactly what they might do. Well, with this, you compile your code with their code and you can look at their code and know their types. And so you can write some of this boilerplate code for them. So that's something that's cool. We get some benefits out of it, so we can alleviate reflection-based performance hits. So things like serialization can take big advantage of this potentially. We can generate complete classes from declarative code such as XML or JSON. This is one of the examples that is in the source generators like samples is a way to generate classes based off of XML. I thought that was pretty cool. So you can like generate settings classes from XML. There's it could make using certain libraries easier. So like that boilerplate code that we were talking about, if libraries can now generate a lot of that stuff for you, you don't have to write that. And so they can generate, you can think of in like a perfect world, they could generate the exact implementations that you need and the exact interfaces that you need to do certain things, and you don't have to worry about it. And that's kind of what we were talking about here. Tailor-made, like you're generating code that's tailor-made for the user of your library. There are some drawbacks though, so that adds a lot of magic into the compiler pipeline. Anybody that's dealt with template metaprogramming from C++ can tell you that the magic is real. Procedural macros in Rust are also very similar. So these things, like, I guess the thing that I would say is that when well, I'll use procedural macros for an example in Rust. When they work, they're amazing. They do all the stuff for you. You don't have to do it. It's great. But when they don't work, it's like a nightmare to try and figure out why, right? And a lot of that is because the code that you're working with is generated. And so it's going to depend on your code. It's not like you can just go out and Google your own code's implementations that get generated, right? So very magical under the cover black box type stuff, right? So that could be pretty scary. Another drawback is that you kind of have to know the Roslyn API a little bit to write these things. Not just a little bit, like you have to know it. That's what you're using. So it's, that if you're a user, you don't want to have to worry about this kind of stuff. But I mean, I imagine this stuff's going to leak through though. So we'll see how that plays out. there's a potential to add a lot of compile time as well. So, I mean, this is super obvious in C++ and Rust, where you can have these things that explode out into many different classes that now get compiled, whereas, you've got all this generated code that has to compile that you personally didn't write, but you kind of needed because, you wrote code that made that code generate. Anyway, the thing is that, this, when you're writing these, you have to keep in mind that you're adding things to their compile time. And so you got to be kind of careful about that. Cool. That was much faster than the original few times that I ran this. So we're going to move on into a project that we have here. What we're going to do to demonstrate this is we're going to look at something that uses reflection, and we're going to port that over to using source generators instead. So we've got, and it's a super simple example. We're not going to go super deep, but it's, I think, going to demonstrate the point. So we've got these two classes here, person and thing, and then we've got this JSON serializer class that we've written. And I'm just going to step through this real quick. This is actually wrong. Basically, what we have here is we create a string builder. We start out an object. We look at the properties of the object that's being passed in, or the type that's being passed in. And then for each one of those properties, we're going to go through and create basically the key value pair, right? So we're going to put the name and then the actual value in there. Pretty obvious, I feel like. If it's null, we put in a null. If it's a string, we wrap it. If it's not, we just call toString. So very simple. We're not handling sub-objects. We're not handling arrays. Like, it's very, very simple and straightforward. So if we go and look at program CS, we run this, build, are we in the right directory? I don't know if we are or not. Cool. Cool. And then .NET run. We should see that we get out, age 100, first name Tony, last name Dwyer. So that's all good. Sorry if you guys hear my dog in the background. All right, so what we want to do, though, is we want to move this code to being run at compile time. We don't want to deal with having to go through all these properties and get all these properties and stuff every time at runtime. And, like, the other thing, too, is, like, we've done this twice now, but if we did another person and another thing, like, we're paying that cost over and over and over, right? And there's not really much we can do about it. I mean, there are ways that you can kind of alleviate that by, like, building expression trees that, like, you have a string or whatever, and you just interpolate the string and you, like, cache how that works. But, like, that's super complicated and stuff, and we're just going to go with these simple examples. So what do we actually want to do? What we would like to do is we would like to generate a class, right, that can do this serialization for us. And anytime I'm working on, like, metaprogramming stuff, I like to write out exactly what I want to be generated. And so we might have something like public class generated serializer, something like that. And then we want this to basically maybe have an overload for every type that we want to support. So we might have something like public string serialize and take in a person, right? And then we want to return something like return. We want to do a opening bracket and then age colon and then person dot age and then a comma, and then we want something like first name colon person dot first name. You get the idea. We're just going to go through here and put all these in here. That's not last name. All right. Oops. Is that right? I feel like I'm missing something here. Oops. Oops. Get over there. All right. So then what we'd want to do is something like, instead of having this one, we'd want to do something like generated serializer. I think my dog's going to want out here in just a second. so I might have to pause the video. Oh yeah, he wants out. I'm gonna pause the video and let him out, and I'll be right back. All right, and we're back. So, where were we at? Oh, we were continuing to write this generated serializer. So, what if we run this? All right, so we get our output, and we didn't have to do any of the reflection, right? And so if we wanted to also add support for a thing, we would just do another overload. Public string serialize thing, return, and then we're going to do the same thing here. So name, thing.name, and then wait, and then thing.wait. Yep. So let's try and run that. You guys can ignore the missing project. That's from one of the 50 million attempts I tried to record this. Okay. And then we can go ahead and add in our table here. Let's try and run that again. Okay, so there we go. That's kind of what we want. We want to generate this code. So let's talk about how we do that. So with this as our template, let's go ahead and see if we can do it. Let me go ahead and comment this out though, just for the time being. Okay, cool. So source generators use the Roslyn API. Let's talk about that for a second. Roslyn API. There we go. So there's really two main parts to this. There's the syntax and there's the semantics. The syntax you can think of is basically like the text representation, right? You've taken the text and you've broken it up into its parts. The different parts are keywords, identifiers, literals, punctuation, white space, comments, preprocessor directives, and stuff like that. All of these get grouped up under nodes, and then those nodes get grouped up into trees, and that's kind of like our syntax tree. So with that, you can take one of those, and when you run that through the compiler, what you can get is the semantics. And so what this is the actual symbols that get created out of the syntax. So there's a lot of different implementations of iSymbol here. So there's field symbol, event symbol, error type symbol, named type symbol, parameter symbol, all the things that you would expect a symbol for. And the same thing really applies to the syntax. Let's see if we can get a node here. Yeah. So this is there's syntax node, and then there's let's see if we can find the derived types. I don't think there's a list. Maybe not, but there's class, there's declaration syntax nodes, right? And then there's class declaration, field declaration, property declaration. There's all these different types. So it's a big hierarchy. I just realized my head was in the way of all that, which is excellent. Well, but anyway, so you can check all this stuff out here at the Microsoft Docs for the Roslyn APIs. So we're going to continue, and we're going to create a new project. So the way the source generators work, you make a library that gets compiled with some other code. And during that compilation phase, your library can hook in and kind of inspect everything and add new source code. So let's go ahead and do that. Let's go ahead and make a new console window here. Yeah. So we got my program. That's where we're at. Yep. Let's go ahead and make, what was our project called here? Oops. It's called Serializer Generator. So we're going to make a directory called Serializer Generator. And we're going to make a new project. It's going to be a class library. Okay, and then we're going to add a couple of references, a couple of NuGet packages there. So we're going to add Microsoft.codeanalysis.analyzers, I think. Yep. And then we're going to do the same thing with Microsoft Code Analysis C#. All right, clear, clear, clear. Okay. Let's make sure that builds and everything. Cool. All right, so back over here, we can go up a directory and look in here. We're gonna rename this to Serializer, JSON Serializer generator.cs. Okay. So now that we've got this here, we have one more thing. We actually have to grab project reference, and I've already got this in here. But you have to have output item type as analyzer, and you don't want to reference the output assembly for that project. So then, so our first step is to go ahead and mark this class as a generator. So that's one thing, and then we'll have to bring in Microsoft Code Analysis to do that. And then we're going to inherit or implement iSource generator. And iSource generator actually has really good documentation. We get two methods out of this. We get execute and initialize. Initialize lets us basically hook in some callbacks that we're going to talk about with the visitor pattern, and then execute basically gets called whenever compilation is happening. And it gets, I believe it gets called multiple times. Maybe not though, but we'll see. So back in here, we're going to go ahead and implement this. So we've got execute and we've got initialize, and that's exactly what we want. So looking back at our program though, if we wanted to generate this class, right, we need some way of telling what all overloads we would want, right? We don't just want to generate an overload for every type of object ever, right? That would be exploding compilation, right? So what we might want to do is something like JSON serializable or something like that. So let's write an attribute that we can append to our class. And so we're going to add this attribute from the library because that's where it belongs, right? But it's going to actually end up wherever we want. So it actually ends up in the user's code. So like this code that we're going to be generating is not going to be in the library. It's going to get generated and put into the user's actual code. So like if you create a namespace in here, that's going to be in their code, not in our code. And we're not going to have access to things that are in this code. So we're literally just writing text that's going to get turned into classes that go in their code, not our code, their code. So let's go ahead and put a string attribute text, and we're going to make this a private const string. So let's go ahead and make an attribute, and we'll show you guys how these actually get plugged in. So we want to create a new class, so public class JSON serializable attribute. It's going to inherit from attribute, which is in the system namespace. And then we want to do something like we actually need to attribute usage, attribute targets dot class, I think is what it was. And then we want just a public constructor. It does nothing. So now that we've got this, when we're going to execute, we get this context, right? And this context is what actually lets us add source, right? So we get context.add source. So we just give it a name. It just has to be like a unique name to this generator. We're going to call it JSON serializable attribute because that's the name of the class. Oh, we're missing one thing. We need a namespace. And let's just go ahead and put this in generated. Cool. And then we're going to add source text dot from attribute text, and then encoding is UTF-8. I think that's it. We're going to have to bring in Microsoft Code Analysis text and system text. And now that we've done this, what we can do, see, that looks all right. Now that we've added this source is going to get compiled with their code. And so what's going to end up happening here, let's actually exit and reopen here. So if we rebuild now, and actually I'm going to do a clean every time now as well. Something interesting has been happening where the tooling isn't exactly caught up with source generators yet, using generated. So this is going to show an error, but it's actually fine. Using serializable. So if we re-clean and rebuild this again, hopefully this will work for us. And the reason I'm doing a clean is that for some reason the generator doesn't get run unless the user's code changes. So while you're working on it, at least that's been my experience right now, and that might change with the tooling updates and whatnot, but unless your code, the user's code actually changes, the generator doesn't get run again. So what I've been doing is doing a clean, that way it gets run every time. So if you're working on a generator, you might want to run a clean with your rebuild. All right, so now that we have this, we can go through all the classes in our code and be like, hey, does it have this attribute? And if it does, we can generate one of these overloads right here, right? So let's go ahead and try that out. This is where it's going to start getting pretty confusing. So I'm going to be moving a little bit fast because this is one of those things where you're writing a string that is a program that writes a string, and it's 3 levels deep and it's kind of confusing. So if you guys have any trouble, just pause the video or go back and rewatch a little bit. But we're going to be moving kind of fast here. So the first thing we want to do is we actually want to collect some information about the classes in our context. And so the way we do that is with the visitor pattern, and specifically with an implementation of the interface I syntax receiver. So we're going to write our own. So public class, I mean, it doesn't have to be public actually. Let's just do class. Let's call it, my syntax receiver. You can call it whatever you want, but it's I syntax receiver. And what this does is it gets called. So on visit syntax node gets called for every syntax node in all the different trees, right? In all the different syntax trees. So the way we register this, our syntax receiver, is actually in initialize. We do something like context.register syntax, register for syntax notifications, and then you just pass in my syntax receiver, a lambda that gives it back. So a delegate that gives it back, I guess, is probably what it is actually asking for. Yeah. So anyway, syntax receiver basically is just a way for you to build up some information about the code, because it's going to get called for everything, right? So what we actually want to do is, so these are syntax nodes that we're visiting, and we want to look at the type of the syntax node and be like, hey, is it a class declaration? And if it is, does it have attributes? And if it does, if both of those things are true, we want to save it for later so that we can build our generated serializer. So let's go ahead and kind of do that. Let's see. So if syntax node is a class declaration syntax, I think is what it is. No, was it? To look it up real quick. No, that is right. I just must be spelling it wrong or something. Class deck, yeah. Declaration syntax. So we can bring in code analysis C# syntax. And like I said, there's many types of syntax node, but we're only caring about class declarations right now. And we want to make sure that it has attributes. So we can do and class declaration syntax that attribute lists dot count is greater than 0, right? And then if that is the case, we want to save the class declaration for later so we can get back to it and generate our code. So let's make a public list of class declaration syntaxes. And we'll call this candidate classes. Was new list. Yep. All right, we gotta bring in collections generic. Cool, and then we'll just add it. So candidate classes dot add and class declaration syntax. So if you're not familiar with the syntax, this is like, you know, dynamically testing if it's the right class, and if it is, it gets assigned to this variable called class declaration syntax, which we can use later on. Cool. So that's like half of the work, well, like a third of the work right there. So the next thing we want to do is actually our context gets a syntax receiver. So if you look at the implementation of this thing, there's a syntax receiver right here. But it's not necessarily the one that we're working with. So we need to check that first. So if it's not, so context.syntax receiver is my syntax receiver. So if it's not that, we're just going to return. But if it is that, now we have access to receiver, which is of type my syntax receiver. So we can get our candidate classes here. So now we're just going to like loop through the classes, check the attributes, and then like generate our code. It's a little bit more in depth than that though. So we're gonna go through it. But the first thing we want to do is maybe get a string builder going so we can build up the string over time. So string builder, we'll say SB new string builder. Have to get rid of one of those I's. And then we want to go ahead and generate our namespace and stuff. This is a little bit tricky because the namespace actually has to be shared with the code that we want to talk to, right? So like to make this make more sense, if we look at program CS here, we have to either use the JSON serializer namespace to get access to these guys, or make it all part of the same namespace. We're going to cheat for now and just make it all part of the same namespace for the sake of not having a 50-minute video. And it may come out to be 50 minutes again anyway. But so let's just go ahead and do that. So sb.append, and then we're going to do namespace with some serializer or whatever, which is an interesting namespace. Probably should have named that something else. And then we're going to do public class generated serializer, right, to match what we had over there. And then we have to end that with something like this, right? And then at the very end, we're just going to say context.addSource with our same kind of stuff from above. So let's actually go grab that. And we're going to call this generated serializer. And this is going to be sb.toString. So now we've got our class. We just have to actually like generate the code that goes inside of here, right? So how do we go about doing this? So we basically want to do like a for each over our candidate classes, right? So for each bar class declaration in what was it, receiver dot candidate classes, right? And then we want to go ahead and make an overload for these. So do something like sb.append, and it's going to be something like, let's actually do public string serialize, and then we want to do like the name of the class declaration. So this is going to be identifier.text, and then we're going to name it input. Okay, and then let's actually go ahead and make this a string literal so that we can come down a line, and then we'll do that. And then we'll say also down here sb.append the end of it. So yeah. All right, and then what we want to do here is basically return a string. So let's go ahead and try out a quick string, right? So append, and we'll say return yo yo yo. Okay. Let's go ahead and clean and build that. Might not build, who knows? I built. Cool. So let's go back over to program CS. My mustache is like super itching my nose. So now that we have this, we can actually go ahead and comment that out, bring this back, and if we clean and run that, we should get out 2 yo-yo-yo-yos or whatever. Did we not run it? No, we did not. Let's run. Cool. So our generated code is ending up in here, and we're actually instantiating that class. Now we just have to actually go through the properties on those classes and generate that string, which is like 2 levels deep and very confusing. So I'm actually going to copy it over. Kind of. Let's see. So what we want to do then, okay, so first off, we kind of skipped something here. We actually need to make sure our class has that attribute. So let's go ahead and do that real quick. So how we do that is we have to actually compile our attribute, right? So syntax has no concept of like what attributes are and like what different things are. It's kind of like it's the text, but we don't like have a model of it. You know what I mean? So what we actually need to do is compile this code right here so that we can get a reference to the symbol that is JSON serializable attribute. So we're going to go ahead and do that. So the way we do that is up here. We're just going to do this actually before string builder. We're going to grab the C# parse options from our context. So with this, basically we're just getting the options that they are using to compile the code so that we can do the same thing. And so what we're going to do is grab a syntax tree from our attribute text. So this is going to give us a syntax tree, and we're going to pass that in to our compiler. And the compilation is actually immutable. We go and look at that. I think it'll tell us an immutable representation of a single invocation. So this is kind of like strings in that when you modify it, it gives you back a new reference to a new immutable compilation. So we now have this new compilation based on our old one, but we've added our attribute to it. And so now that we've added that, we can actually go in and get symbols out of it. And this is a semantic thing. So symbols are a semantic issue. These actually are aware of like the compiled code and like how it all fits together. And so what we're going to do, this is going to be used later, is get the attribute symbol. So we're going to get a type by meta name, and we're going to get our this is JSON serializer.json serializable. Nope, this is generated.json serializable attribute. So we're going to get this attribute symbol so that we can compare it with any attribute symbols on our class. But you might be thinking we don't have our class symbols yet, and you're right about that. So we actually need to go ahead and get those as well. We can get a semantic model. Get semantic model for our class declarations syntax tree. So this is like we're gonna get the semantic model for the entire tree. This is like everything that's in there now. We can get a symbol or whatever from it. So now we're gonna do an iType symbol equals class symbol equals model.get declared symbol. Oops. Symbol, and we're going to pass in our class declaration, and then we have to cast this as an iType symbol. So this is saying, hey, I have this semantic model, it knows about my class, I just want to get the model of my class out, the symbol for my class out. And the symbol has things like interfaces, attributes, members, types or whatever. It has all sorts of stuff. So this is very much closer to like the reflection side of things, whereas before we were just dealing with like syntax side of things. All right, and so what we want to do is check if our class symbol has our attributes. So we want to say if not class symbol dot attribute or get attributes dot any. So we got to bring in system.link link. And we'll say a dot attribute class dot equals, and we're going to say our attribute symbol. So this is comparing these two symbols. So the attribute class is a symbol, right? And we have a symbol for our attribute that we want to compare it against, and then we have to actually use a comparator. So this is named what is it? It was a symbol equality comparator dot default. So if there's not this attribute, we're just going to continue. Is basically what we want to do. So do not generate an overload if we do not find our attribute on the class in question. That makes sense. So now that we know we have that, we can actually start to build our thing out. So then what we're going to do is we're going to go ahead and do something like this. So we know we want to do something like, let's grab our string from in here, right? So we want something that's kind of like this, right? But not exactly. So we're going to do something like for each var, we're going to say property syntax or property declaration in our class declaration dot members dot of type. So members is like all types of decorations and whatnot that are part of the class, because it's a tree, right? So it knows. But we only want the ones that are property declarations. So that's why we're doing that. Excuse me. And so then what we can do is sb.append. So first of all, let's get our return statement going. So let's do sb.append, and we're going to say return, and then it's going to be an interpolated string with a quote. And see, this is where it's going to get tricky, right? Because if we wanted to put the name in here, so this is going to be this here. If we wanted to put name in here, we actually have to do like this, because we need the backslash and the quote to go into the interpolated string that we're creating inside of this string. So it's very confusing, very like stringception, right? So we're going to keep that in mind. So anyway, we're going to do that right there, I think. And with a space, yeah. And then down here, we don't have to care about this anymore. We can just put our space in there. Whoops, right there. I feel like we need... This is not quite right. We need another thing here. We got append. Now, yeah, that's right. Okay. So that's what we want. And then we have to end our string and put a semicolon. So I think we're getting closer here. Let's go ahead and just, whoops. Get my caps lock on. .NET clean and run that. Let's see if that even builds. I don't know if it will. Looks like it will. That'll probably give us empty objects. Cool. So we're part of the way there. Now we just have to append for each of the types. So we're going to do sp.append, and we're going to do a quote, right? And then property declaration dot. Once again, this is going to be identifier.text, right? And then we're going to close that quote inside the string. So we got to do the double backslash quote again. And then we're going to do a colon. And then we're going to do, so we've got input, right? Up here is the name of the thing we're passing in. So now we can do input dot, and we can say, this is going to be property declaration dot identifier dot text. Yep. Is that right? I feel like I'm missing something here. I am. This actually means these right here. Yeah. Okay. And we need to put that there. Cool. Let's see if that runs. I kind of think it's not going to work, because this is so like tedious and like easy to get wrong. Hey, so we're like halfway there. We've got the properties there. We have cleaned it up a little bit. So we want like a comma, right? But our strings don't have quotes around them, and our commas are a little bit weird because we have one at the very end and we don't want one. So what we want to do then is we're just going to bring this out. We're going to bring this thing out to a local. So property declarations, and we're going to say for int I equals 0, I is less than property declarations dot count, I plus plus. And we're going to say property declaration equals property declarations I. What's wrong here? Oh, it's I enumerable. To list. So now we can say if I is greater than 0, we can sp.append a comma and a space. And then if we get on here and find our comma and space and get rid of it, I think we're like a lot closer now. So that should give us our commas fixed, I think. Maybe. Okay, cool. But we still have to quote our strings. And so what we have to do for that, we want to make sure that we're actually a string. And so that's where this named type symbol, string symbol comes in. So the same way we were comparing for the attribute, we're going to do the same thing for our property type. So we're going to say, we're going to get the symbol for our property. So I property symbol equals model.get declared symbol, and we're going to pass in our property declaration dot, that's it, that. And then we're going to say if our property symbol dot type, I think, yeah, type dot equals string symbol with our comparator again, our what was it, symbol quality comparator dot default. Then we're going to do one thing, we're going to put quotes around it. Else we're going to do another thing. So we'll just go ahead and put quotes here. We'll try and run that. And it failed. Hold on, we got a bad thing here. Yep. Looks right. These need to go on the other side of this. Oops. Hopefully that'll work. Cool. So there we are. Like, this is kind of the whole deal, right? Like, we are now actually generating a class that looks exactly like this, right? And that is super cool because now we're not paying any price for reflection at runtime for these. We're just writing out the string. Like, it's about as efficient as it can possibly get. The one caveat is, like, if we take away JSON serializable on this thing, we're going to end up with a compiler error because it doesn't have an overload for this, right? So it says it cannot convert from JSON serializer thing to JSON serializer person. And, this is kind of what I was talking about with like cryptic error messages and hard to like figure out why they're going wrong. Like, if you were a user of this library, that doesn't make any sense at all. Like, can't convert thing to person. Like, what does that even mean? The pipeline does actually let you give out diagnostics though. So like, if we wanted to do something like, you can actually do like context dot report diagnostic, and so you can like you can make your own compiler errors if things are not exactly the way they're supposed to be. So that is that's kind of the gist of that. So you can actually help clean that up a whole lot, but it's going to be up to the implementer of the library. So videos, what's this? Source generators, outline of text. So with that said, I think we've covered just about all of it. A lot quicker this time, so I hope it was clear. It's still a very long video, and I went about as fast as I could possibly go. So let me know what you guys think about having longer videos, if you think I should slow down for topics like this that are super deep, or if you mind having longer videos or maybe splitting them up. Yeah, I mean, if you liked this video, please give it a like. If you like what I'm doing here, if you like, seeing me develop this stuff and go over best practices and whatnot, feel free to subscribe. There's going to be a lot more coming out. Yeah, I think that's all I got. So thanks for watching, and have a good one.